Children, how are you today? I hope you are fine wherever you are. I am Teacher Sangita, your mathematics teacher. I am from Sekolah Menengah Kebangsaan Raja Ali, which is located in Kuala Lumpur. So, are you ready for the lesson? By the end of today's lesson, you should be able to describe the Pythagoras Theorem by referring to the relationship between the sides of a right-angled triangle. Next, determine whether a triangle is a right-angled triangle by using the converse of a Pythagoras theorem. Hence, you are able to solve problems. Let's look at this picture. It is a television. Have you seen in the advertising brochures that it is mentioned the size of the television is 21 inches? The 21 inches refers to the length or the width. Actually, it's neither. The 21 inches refers to the diagonal line just like in the diagram. Now, I am going to extract a triangle out of the squared television like this. Notice that this is a right-angled triangle, which means one of the angles is 90 degrees. The side opposite of the 90 degrees is called a hypotenuse. This also refers to the diagonal line that we discussed just now. Have you seen laptops and computers being sold in shops? Normally, the specification of the gadgets will be advertised. For example, laptop XEA, size of the screen is 13 inch. So, what does the 13 inch refers to? Exactly! The 13 inch refers to the diagonal line across the screen. See, the use of diagonal lines are everywhere around us. Interesting, right? Now, let's take a look at this question. For the following diagram, identify the hypotenuse. Here's a tip. Always look for the 90 degrees angle. Again, the opposite side of the 90 degrees angle is called the hypotenuse. So, which one is it? Very good! It is B. B is the hypotenuse. Let's have a look at this diagram. For the following diagram, identify the hypotenuse. Again, observe the 90 degrees angle. The opposite side of the 90 degrees angle is called the hypotenuse. Thus, the answer is Q. Did you get it right? Very good. Are you ready for the next question? Observe the diagram closely. For the following diagram, identify the hypotenuse. Children, what makes a line a hypotenuse? Yes, the hypotenuse is the line opposite the 90 degrees angle. I can clearly see S as the hypotenuse of the diagram. Do you think S is the only hypotenuse here? Let's find angle X. Do you still remember the properties of a straight line? Use the properties of the straight line to find angle X. So, angle X is 180 degrees minus 90 degrees. Angle X is 90 degrees. Aha! So, we have another 90 degrees angle. What is opposite the 90 degrees angle? Oh yeah, it's line B. So, B is also the hypotenuse of the diagram. Did you know painters use ladders to paint on high buildings and often use the help of Pythagoras Theorem to complete their work? The painter needs to determine how tall a ladder needs to be in order to safely place the base away from the wall so it won't tip over. So, what is the Pythagorean theorem all about? Children, now that you have identified the hypotenuse for a right-angled triangle, let us move on to the next part of the lesson. Next, we will be learning about the Pythagoras Theorem. What is a Pythagoras Theorem? Let's start with a little activity. Here, I have a paper with 50 squares and also a triangle. I want you to cut the squares individually like this. Now, I want you to arrange the squares on each side of this triangle. Take note that each side should form a big square like this. Once you complete the arrangement of all the 50 squares, you should be getting a diagram like this. Now, here's where we start proving the Pythagoras Theorem. Count the number of small squares used in each side. We find out that there are 9 squares, 16 squares, and finally 25 squares. Each of these squares is considered as the area. How do we get the area of a square? Indeed, it is length times width. Now, let's find out the length and width of the first square. It is 3 times 3. Similarly, for this square here, it is 4 times 4. Finally, the biggest square is 5 times 5. Now, I'm going to extract the squares like this. So, 3 times 3 plus 4 times 4 will give us 9 plus 16. The answer for 9 plus 16 is 25. Did you notice the biggest square has 25 squares in them? Which is 5 times 5. Amazing, right? Now, I am going to denote each side of the square as A, B, and C like this. Let's repeat the same process as the previous example. We will find the area of each square. A times A plus B times B equals C times C. Finally, we have A squared plus B squared equals C squared. Voila! This is the Pythagorean theorem. Take note, pupils. Pythagoras theorem can also be written as C squared equals A squared plus B squared. Now that you have learned the fundamental theorem, let's answer a few questions related to this. Are you ready? Look at this diagram. Find the value of x in the following diagram. The first fundamental step is to identify the A, B, and C in the diagram in order for us to use the Pythagoras theorem. We will start by identifying C. That's easy. C is always the hypotenuse, which is the side opposite the 90-degree angle. The other two sides can be written as A and B. Now, we will be using the theorem. Substitute each of the length in the theorem like this. X squared equals 12 squared plus 5 squared, which is 169. But we want the answer for x. Thus, we need to square root 169. The answer for x is 13 centimeters. Good. Let's look at this diagram now. Find the value of x in the following diagram. Again, identify the C in the diagram. What is C again, children? Bravo! It is the side opposite the 90 degrees angle. The other two sides are written as A and B. Now, substitute the value in the theorem as such. To find x squared, we need to minus 24 squared from 26 squared like this. Now, the value of x squared is 100. Again, we want only x. So what do we do here? Excellent! To find x, we must square root the 100. Lastly, the answer for x is 10 centimeters. Are you ready for a challenging question? Trust me, the question is easy if you put your thinking caps. Shall we? Find the length of QS in the following diagram. Notice that there is a 90 degrees angle. Use it to your advantage. What do you think the answer is? Now, before we find QS, we need to first find the length of PQ. You might ask, what do I need to find PQ? PQS is a right-angled triangle. And to find QS, we need to first find PQ. We can use Pythagoras Theorem to find PQ. 24 squared plus PQ squared equals 26 squared. We need to minus 24 squared from 26 squared, which equals to 100. To find PQ, we need to square root 100 and the answer is 10 centimeters. However, that is not the answer, is it? We repeat the same steps, but this time, our focus is on the triangle PQS. Since PQ is the hypotenuse, we can say 10 squared equals to 6 squared plus QS squared. I think you know the drill by now on how to find QS. We need to first minus 6 squared from 10 squared and then square root the answer in order to get QS. Thus, QS is 8 centimeters. Easy as ABC. Do you think you are up for another question? I'm very sure you are. Let's look at this diagram. Find the length of QS. Give your answer in 2 decimal places. We need to come up with a strategy. I can see 2 right-angled triangles. In order to find QS using the Pythagorean theorem, I need the length of PS and PQ. PS is given as 24 centimeters. How do we find PQ? Aha! I should see the bigger right-angled triangle. In my opinion, we should first find PR. We are going to use the triangle PRS. 24 squared plus PR squared equals to 30 squared. PR squared equals to 30 squared minus 24 squared. This will give us 324. We then square root 324 to get 18, which is the answer for PR. To get PQ, we divide 18 by 2 and we will get 9. So, the last step would be to find QS. QS is 9 squared plus 24 squared. Then, we square root the answer. Finally, the answer for QS is 25.63, correct to 2 decimal places. Children, so far we have learned the Pythagoras theorem. Now, let's learn the converse of the Pythagoras theorem. First and foremost, do you know the meaning of converse? According to the Oxford Learner's Dictionary, converse means opposite. So, in the next part, we are going to find out whether a triangle is a 90 degrees triangle based on the given length of all sides using the Pythagoras theorem. If C squared equals A squared plus B squared, then the angle opposite to the side C is a right angle, like this. You will understand further with the next question. Let's look at the diagram. Determine whether the following triangle is a right-angled triangle. First, we need to determine which side should be labelled as C, that is the hypotenuse. Take the longest side as C. The other two sides can be either A or B. The Pythagoras theorem is as follows. We will be comparing the answers on the left-hand side and right-hand side. Left-hand side, C squared is 17 squared, which is 289. Right-hand side, A squared plus B squared is 15 squared plus 8 squared, which is 289. As you can see here, the answer on the left-hand side equals to the answer on the right-hand side. Hence, the triangle is a right-angled triangle. Now, take a look at this question. Based on the diagram, explain whether PQS is a right-angled triangle. We will repeat the same process as the question before this. First is to identify the hypotenuse, C, and the other two sides, A and B. Then, substitute inside the theorem. We will compare the answer from the left-hand side and the answer from the right-hand side. Left-hand side will give you 289, while the right-hand side will yield 233. Aha! As you can see, the answers on both sides are not the same. Hence, PQS is not a right-angled triangle. So far, so good? Okay, children, let's see how the converse of a Pythagorean theorem can be applied in daily life situation. A carpenter wishes to fix a triangular piece of wood measuring 12 centimeters, 16 centimeters, and 20 centimeters onto a L-shaped wooden structure as shown in the diagram. Explain whether the triangular piece of wood can be fixed perfectly onto the L-shaped structure. Children, is an L-shaped structure be considered as a right-angled triangle? Of course it is. That means I can use the Pythagorean theorem to prove the triangular piece of wood can be fixed perfectly onto the L-shaped structure. Pythagorean theorem says A squared plus B squared equals C squared. C is the hypotenuse, or in this case, the longest length, which is 20 centimeters. We need to prove the left-hand side equals to the right-hand side. The left-hand side is 16 squared plus 12 squared, which equals to 400. Will it be the same on the right-hand side? Let's try. Right-hand side is 20 squared, which equals to 400. Bingo! Left-hand side equals to the right-hand side. This means a right-angled triangle can be formed from the triangular piece of wood. This right-angled triangle wood can fit perfectly onto the L-shaped structure. Give yourself 2 thumbs up if you answered correctly. Children, now that you have learned about the Pythagorean theorem and its converse, let's put all this knowledge together in the next question. Before we do that, we are going to stretch our fingers so that we are ready to answer the question. Okay, I'm all done. Are you ready as well? Look at this question. In the diagram, calculate the value of x. In order to get the value of x, we first need to find the angle at SQR. First, we need to determine whether triangle PQS is a right-angled triangle or not. We will use the theorem to compare the answers from both sides like this. Turns out, the answers are the same. So, PQS is a right-angled triangle. Now, find the angle SQR. 360 degrees minus 90 degrees minus 155 degrees. The answer is 115 degrees. Finally, to find x, minus 28 degrees and 115 degrees from 180 degrees because it's the sum of the interior angle of a triangle. Voila! Your answer is 37 degrees. Let's do one more question. The width of a river is 18 meters. Imran swims across the river from point P to point Q as shown in the diagram. Due to strong water currents, Imran eventually lands at point R, which is 6 meters away from point Q. Explain how you would calculate the actual distance Imran swam. Give your answer correct to 2 decimal places. Children, we definitely need a plan to answer this question. Do you have any idea? Perhaps we should label the diagram with the given information. Width of the river means the length of PQ. So, PQ is 18 meters. QR, on the other hand, is 6 meters. The question wants us to find the actual distance that Imran travelled, which is from point P to point R. That means we need to find PR. The diagram PQR is a right-angled triangle, and PR is the hypotenuse. So, we substitute the given value in the Pythagorean theorem. PR squared equals 18 squared plus 6 squared. PR is the square root of 360. As a result, PR is 18.97, correct to 2 decimal places. Phew! We have reached the end of the lesson. Now, let's put our thinking hats again. What did we learn today? You are now able to determine the hypotenuse of a right-angled triangle. Then, you studied the Pythagoras Theorem. We also learned about the converse of the Pythagoras Theorem. Finally, we answered a few questions based on the Pythagoras Theorem and its converse. So children, I hope you enjoyed today's lesson. Till I see you the next time, goodbye from me.